In previous video, we calculated VR, regional wind speed, which is 46 meter per second. We calculated the wind direction multiplier, which is MD. We calculated MD equal to 1. We also calculated MZ cat, which is terrain height multiplier, which we calculated 0.91. Now this video we are going to find the remaining two parameters, which is ms and mt. So for finding this shielding multiplier ms, which is the next parameters to calculate the design wind speed, which is ms, is a shielding multipliers. Now in the question it says that there are no upwind buildings at all for westerly winds, so ms equal to 1.0. so there is no any shielding buildings in front of this church building, so therefore it ms equal to 1. If you need more information, you can find it on section 4.3 on page number 21. So on section 4.3 on page number section 4.3 on page number 21, it has provided some information about the shielding multiplier ms. So ms equal to 1, we calculated this ms equal to 1 now, and now we are moving on to finding the topographic multiplier mt. Now that topographic multiplier mt, that is step number 6. Step number 6, we have find the topographic multiplier mt. Now we need to use the section 4.41b page number 22, where it help to find the topographic multiplier. Now on page number 22, it has a section 4.1 on topographic multiplier. Now the section A is for New Zealand and Tasmania, and the building church is located in Perth, so we are using this 4.41b, where it says that larger value of following. So mt can be taken as a maximum of mh and mle. mh is equal to hill shape multiplier, and le multiplier for mle. Now that is written here, which is written here, mt is equal to maximum mh mle. So we're going to find the mh and lle from the section 4.42 on page number 22. The information is given here, and for mle section 4.43 on page number 23. So that is on page number 24. It has some information to calculate the le multiplier. So it's actually, this one is on page number 24. Now to calculate this one, we need some basic informations, and some informations are given here. For topographic multiplier mt, the topography correspond to an S-curve with the buildings near the case. Use the figure 4.3 on page number 23. So in our scenario, we have two figures. On page number 23, there are two figures. One's for the building which are on hills and ridge, and second is called escarpment's case. Now our building is on the escarpment. How this our building is on escarpment? I can show it here in a minute. Now to calculate the mt, upwind slope 5 is required. We need to calculate. Now here height of the escarpment is 14 meters. As you can see in this diagram, which I draw it here in the hill. It's just a quick explanation here. This contour line shows that the height is 14 meters. So that height, which I can make it here, that height shows that this contour line is 14 meters. So that is the explanation of 14 meters. Now this height is explaining that this would be have at 10 meters, right? And the distance between this is not given by scale. By scales we can find the horizontal distance between these lines. And similarly, we can have a 10 meters, then you have 8 meters. So we have 8 meters here, where you have 10, 8, and then 6 meters line, 6 meters line here, and that is 6 meters line here, and there is a 4 meters line, and there is a 2 meters line. So if I draw a line here, that is 2 meters, and that is a coastline here. So these contour lines are so on. This is actually, this measurement is actually the height of this escarpment. Escarpment is nothing but there is a difference, like if you have this slope, so that is called escarpments. And if you have another scenario where we have this scenario where these buildings, it has a called hills and ridge. So there are two cases. So in our example, it's given in this scenario. So we have this horizontal distance come into the pictures. Now in the questions is saying, so we can say that LU is 100 meters. Now to calculate the MT, we need to calculate the upwind slope 5 that we're going to calculate. Here the height of the escarpment is 14 meters. That is given here. Height is 14 meters with respect to the figure here on figure number 4.3 on page number 23. It says that height h is equal to 14 meters, and it's again taken from this contour height 14 meters. Scaling off to the side plan gives LU equal to 100 meters. Now the concept of 100 meters is the one that the building is located on the crest here, and this is 14 meters. So if you need to take the half of the 14 meters, so that is 7 meters. So the distance between the location of the building to the point where you get the 7 meters, or half of has to that horizontal distance is LU. So if we're taking the map here, we have 14 meters here and we have 0 meters here. Half of 14 meters, which is H, is a 7 meters. So we need to find the contour lines at 7 meters. So we have a 10, 6, 8, 4 and 2 meters. So there would be the between that is 8 and 6. So we have a 7 meters line here. So that 7 meters line is located, if you are scaling up, that is not we will that is not given in the questions, but we are giving this information that this one is 100 meters by using this scaling. So there should be given in the questions, but we are taking this LU value 100 meters in this case. So the LU is 100 meters. So LU is 100 meters that we just calculate, that we just found it. Now once we got all the informations, we can find this upwind slope 5 is equal to H on 2 LU. These equations, where we are getting these equations from on page number 22 on section 4.42, we have this upwind slope 5 equal to H on 2 LU. So that H on 2 value, which is 14 meters, that we 14 meters we calculated just that is 14 meters we just noted here. Where this is coming from, I think we have on the diagram. On the diagram we have this 14 meters, and that is given on the contour, that is 14 meters. LU we calculated 100 meters, that we just calculated LU, which is the horizontal distance. That LU we found 100 meters. Getting this ratio give us 0.07. So section 4.42 on page number 22, that is here we will have this 5 value. So you have three options, that 5 value less than 0.05, the 5 value between 0.07 and 0.45, and greater than 0.45 respectively. We need to use those figures. Now here see figure 4.2 and 4.3. so in this case we are going to Hill shape factors. Our H on LU value is 0.07, so we're going to use these BMH equations. Now to calculate the MH, we know the value of H. Z is the height of the buildings, which is 5.25 meters. L1 and L2 we don't know, that we're going to calculate it here. And the distance X. What is distance X? I can show it in the figure. So distance X is nothing. So the buildings, so the distance X is the one that is where the crest is, from that crest to the location of the buildings. Our building is located on the crest, so our X distance is 0. But if if the crest, for example here we have a crest here and our building is located somewhere here, let's say 5 meters between this and this, so the horizontal distance is 5. So in that case we're going to take X equal to 5 meters. But our building is located on the crest, so in our case X is equal to 0 meters. But in the questions it says that the building is located on escarpment at a distance of some distance from the crest. That distance is the X that we're going to substitute. But in our case X equal to 0. Now we need some information, which is length L1. So length L1, that we have given some informations here on page number 22. If you have a length scale to determining the vertical variation of MS to be taken as the maximum between 0.36 LU and 0.4 H. So we can have 0.36 LU times and 0.4 H. LU we calculated 100 meters, so 0.36 times 100, and height H is 14 meters, so 0.4 times 14, which give us 36, and 5.6, which give us 36 meters as a L1. Now L2, just a few lines below, L2 is given land scale to determining the horizontal variation of MH to be taken as 4 L1. So we just calculated L1 36, we substitute 4 times 36 is the 144 meters. Now hill shape factors is given on 4.2.2 on B, page 22. So that is the hill shape factor here on page number 22. 4.4.2 on B, we have these big equations that we're going to use it, and distance x equal to 0 I just explained in the previous step. Now we have these big equations that is coming from the section 4.42 on B on page number 22. We're going to substitute this one, 14 meters H, and that's we calculated, that's we found it here. H is equal to 14 meters, that is given in the questions with this contour, with the contour line, and with reference to the figure here, that is on the figure 4.3 on page number 23, we have these H notations. So that is the H 14 meters, 3.5, Z is 5.25 meters. I think we calculated previously on our examples in the previous steps. We calculated the height of the buildings, 2.7 and 7.8, 5.25 meters. So Z equal to H. So that is 5.25 meters. L1 we calculated 36. It's just now we calculated in the previous steps, which is L1 we calculated 36 meters. 1 plus x is 0. As I mentioned, this is the horizontal distance from the crest on escarpments over 144. We calculated 144 meters in the last steps. This 1 minus 0 is 1 times 1, so that is just 1 here. 14 over 3.5 times 5.25, 36 is gonna get MH equal to 1.41. Now Lee multiplier factors, Lee equal to 1. That's how we going to find it. This one, that is on the section 4.43 on page number 24. On page number 24, on this section here, I read those two lines that Lee multipliers shall be evaluated for New Zealand site on the Lee zone as shown in the figure number 3.1b. For all other sites, the Lee multiplier shall be taken 1. So that's, we are just using this sentence here that our site is on the pot. So that is in case Lee multiplier is 1. So MT is the maximum of MH and M Lee. How this one coming from? I think on page number 22. On page number 22, we have 4.41v, where we are taking the maximum value of MH and Lee multiplier. So maximum value of MH and Lee multiplier is give us 1.1. Now to find the design wind speed, V design theta, we have a equations, regional wind speed times MD, MZ cat, MS MT. We found 46 meter per second. That is in the last video. Last video we found that VR is equal to 46 meter per second. That is 46 meter per second. MD, we calculated MD. We calculated MD equal to 1 in the step number 3. That is MD equal to 1. MZ cat in step number 4. MZ cat we calculated 0.91. MS shielding multiplier, we calculated MS equal to 1, and MT we just calculated MT 1.1. Substituting all this value, calculations give 46 meter per second. That is the design wind speed. Thank you.